Alright, Solen-Safe Home Security by Kendall Gibson, the one and only. Alright, problem statement. I work for Secure Smart Homes LLC. A customer named Alicia Hughes has commissioned our company to create a home security system where her daughter's lock will not be able to be picked. Alright, then we have my logo. I have two S's to abbreviate Solen-Safe, and then I have that house that features a keyhole as the door, and it looks like a lock to show that it's a home security company. Alright, research information. Operation and application, this is where I went into just the basic features of home security systems, like motion sensors, which detect motion, obviously, and that uses ultrasonic tech. Glass break sensors that detect high vibrational frequencies to indicate whether or not the glass breaks. These can be especially useful in like jewelry stores and stuff. Security cameras, they transmit video surveillance to monitors that are in remote locations. Security cameras are more like households, whereas surveillance is like school systems, government buildings, and big corporations, And then I went into some of the main types of locks. We have the cylinder, spring bolt, mortise, and deadbolt. I'm sure you've heard of a couple of those. And all of those are mainly made with steel, brass, and a bunch of other strong alloys. Alright, so now we're going to get into the history and current events. So, the first lock ever was called the pin tumbler lock. And it was made of wood, which is really cool, but it is a little bit fragile. It wasn't the strongest lock. So the Romans were actually the first ones to work with metal when they were making locks. And then after this, there was pretty much no progress during the Dark Ages because a lot of people were poor. They did make their locks a little bit more intricate to try to prevent lockpicks from getting in, but they didn't come up with any new designs. The development of locking mechanisms was kind of sparked during the Industrial Revolution in Great Britain, which is when a bunch of new types of locks were invented. Robert Baronin created the double-acting tumbler lock, which was, I think it couldn't be picked for 67 years. It's either Robert or Jeremiah Chubb with his detector lock, which is also a really great innovation at that time, and then Harry Sorev created the first padlock. And then eventually, security morphed from like locking mechanisms only to a bunch of technology like surveillance and sensors, things like that. And that began around the 1940s and was sort of implemented into residential settings around the 1970s. Alright, impacts. Home security systems are very important because not only do they provide a sense of security, they actually increase a person's safety by 70%. If a robber wants to rob a house and they see that the house is protected by some kind of home security company, they're not going to rob that house because there's a higher chance they'll get caught. So it also decreases robberies by 60%. And security organizations provide services that protect families and homes. They contact police, they make sure that everything is covered, and they put a warranty on things just so that if they were to get robbed, it would, the company would like take it upon themselves. Okay. Individual organization contributions. I chose Marie von Britten Brown. She is the inventor of the first home security system, which is really cool because she's a woman and she's a person of color. During like the 1930s, 1940s, 1950s, somewhere in the 1900s, I'm not really sure. But her first home security system featured cameras, monitors, two-way mics so she could talk to the other person on the door, adjustable peepholes for people of different heights, and a panic button which would contact the police if she pressed it. She also created a lock that would unlock the door from a remote location so that she didn't have to be... There's a fly. So that she didn't have to be right next to the door in case there was like a firearm or something. And she was later awarded, but she wasn't able to profit off her invention because, again, she was a woman and a person of color during this time, so it was a bit difficult. Alright, initial sketches. This is kind of like the layout I wanted to do. Ended up looking completely different, but it shows these little flaps on the side, which is how I was going to secure it to the wall. This shows how the wiring would come from the other side of the door to this side to lock it. If I had it my way, I would put it into the door, but I can't really modify my house without my mom getting mad at me. So there's that. Then this is my low fidelity prototype. It just shows like the electronic housing and the solenoid, which are the things that are going to come out of the housing. You're not going to see any of the electronics really. Alright, and then I have my final design, and it shows how I was going to build it initially using 1/2-inch plywood or particle wood with cutouts for the LCD RFID sensor and the indicator LEDs. And then the flaps, they weren't really shown in this drawing. We're going to come out of this side to secure the unit to the wall. Alright, here's my first on-shape drawing. I was going to build it out of wood. Then I realized I don't have any tools to build it out of wood. So I ended up redesigning it, and I was going to 3D print it. But then I realized, oh my gosh, I ran out of time. So what I ended up doing after all of this, I'll show you later. Okay, this is the wiring and schematics. They show how I connected all the electronics to the Arduino. Right here is the RFID sensor. Then we have the breadboard. That ended up changing a little bit. I ended up using a different breadboard because I couldn't find my smaller one. So there's that. Then I have the LCD, which is connected to the Arduino as well. The relay connects to the Arduino, and then the solenoid actually connects only to the relay and a separate power supply so that it can be powered and work just fine. Alright, and the LEDs and buzzer were also connected on the breadboard. Alright, here we have my code. This was the biggest pain in the butt, but I figured out how to do it after about a week. I had to download a bunch of libraries for the RFID, the LCD, stuff like that, so that I could work with that and allow the commands to work. I defined all of my inputs and my outputs, and then I started a loop so that the LEDs would turn on and turn off the way I wanted. The relay would flip when I wanted, delay when I wanted for 10 seconds so that you had time to get in, and all of that. I created an if-else command so that if it picked up the correct sensor, which is 398301A4, then it would go through this process, but if it didn't, then it would go through this process, meaning that any different keycard than the correct keycard would not work and would not open the relay or close the relay. Alright, now we have my flyer. The flyer lists the company's name, which is Solen-Safe Home Security. It shows our logo right over here and our 3D model and the solenoid itself, just to give people an idea of what they would be getting. And then I have a list of features that tell people like what comes with the product, and I also have the price right here as $69.99. Purchase while supplies last, because there is only one and I don't plan on making another one. Okay. Building. The first week I focused on wiring and coding a lot. I got a lot done in that period of time, and then I didn't work on it for like a week, and now I'm rushing to finish everything in the last week, which, you know, it makes sense because that's what always happens. But as you can see right here, here's just all the wiring. Up here we have me sketching out where I wanted the holes to go, where I was going to drill everything. And then over on the right, I showed the 2 holes that I had in the bottom that I was going to use to secure it to the wall. I never ended up actually securing it to the wall just because my mom would get mad at me for messing up the drywall and the paint. So, but just know that that's there. Okay, and then I got into testing and evaluation. The first thing I did was actually test the code before I assembled everything in the box and stuff. The one thing I noted was that the LCD didn't clear after 10 seconds when the relay switched back. So I just added the LCD clear command, and that solved the problem. And I also tested the solenoid by connecting it to power first and then through the relay, because I had tried a couple other relays at the time that didn't work very well. They required a really specific amount of voltage that I wasn't really able to work without getting a really specific kind of battery. So I ended up getting a 12-volt solenoid, which still barely works. Cheap Amazon electronics, man. Then I tested, I noted that the solenoid would work, but I had to push it in slightly because the field it was creating wasn't enough to compress the spring and pull the solenoid in. But with a little tap, it worked just fine, but it wouldn't work on its own. That's just faulty electronics. Alright, and here's a video of testing. Okay, so this is what we have going on here. This is the correct key fob. I put it on the RFID. The relay turns on, but in order for this to close, I have to push it in a little bit. And then once the relay reopens, then it comes out just fine, but it's just not strong enough to go in by itself. Alright. The magnetic force. Okay, now I wanted to talk about some of the problems I encountered, because believe me, there was quite a few. Firstly, I didn't have a way to build the electronics housing, which was kind of a big problem because it was an entire constraint. I also knew that the solenoid wasn't strong enough to retract the locking mechanism, which is still a problem. Excuse me. And I also had trouble powering the solenoid with batteries. So to solve all of these problems, I tried to redesign and 3D print the housing, which didn't work because I ran out of time. And then I ended up buying a pre-made box and modifying it. And if I had time, I would have replaced the solenoid and gotten a new one, gotten it working properly. And then I also used a wall plug instead of a battery pack because that seemed to work the best out of everything. Alright, and here is the final prototype. I'm actually pretty proud of how it came out. It was a pain in the butt. I had to go to my friend's house to borrow his drill and his jigsaw, and even then the jigsaw was really hard to work with such small holes. And I had to end up filing down all the edges so that the electronics would fit in, especially the LCD. My arm is sore from that. The biggest workout I've had in like a month. Anyways, shows the electronics inside. The wiring is visible in the first shot just because I wanted to show that off a little bit. Kind of my pride and joy. I have the correct and incorrect keys right next to it and the solenoid on the right. And then I have the RFID sensor, which is showing, facing out so that the key card can be sensed. And then the LCD and the LEDs are right under the LCD. It's kind of hard to see with this lighting, though. And there's holes on the back for it to be secured, as I mentioned earlier, to the wall. And then there's a hole on the side to where the wall plugs can come out and the solenoid wiring can come out and be wired to the other side of the door. Okay, these are some things of note that I didn't mention in my description video because I was kind of just trying to get through it. These can all be seen in the demonstration, I just didn't really point them out. So the solenoid does feature a ramp or an angled edge, which meets the simple machine design constraint. And the door can be opened from the inside by simply pushing it in. Since it's spring-loaded, it's really easy. You just push it in and the door comes right open. There's 2 holes located in the base of the box to allow it to be secured to the wall. Covered that a few times already. The solenoid wiring is long enough to reach around the door frame. I have tried it. I just didn't end up adding it to the wall because of didn't want to mess it up. And then the backup method of entrance would be to manually flip the relay by accessing the electronics. This would mean taking off the lid and pressing the manual release on the relay. Alright, and here's my demonstration.
Okay, so here we have the Solen-Safe home security lock. Right now it's plugged into 2 wall plugs because I just fried my 5-volt battery. One of them is powering the Arduino, one of them is powering the solenoid. On the front, we have the LCD display, we have the RFID sensor, and we have 2 of our LEDs that are going to indicate whether access is granted or denied. On the inside, we have a buzzer that buzzes every time a keycard is sensed, and we have a relay that's going to control the solenoid, going to control the power flow from and back from the solenoid. All right. Where did I put the key fob? There it is. All right, we're going to start with this, the correct key fob. So when the correct key fob is sensed, the LED turns green, the buzzer buzzes, and the display reads access granted. I don't know if you can see that. Okay. And that means the power is, oh well, I have to start it again because it looped, but that means there's power to the solenoid, so it's going to close. It's not strong enough to retract fully, but that's the solenoid's fault. And then after a few seconds, it retracts again. So that is the access denied, and then, that's the access granted. And now I'm going to show the access denied. This is the wrong key card. And when the RFID senses it, a red LED lights up, the buzzer buzzes, and it says access denied. And the state of the solenoid does not change. It remains retracted. See? And then right here we have the housing. It's made out of a wooden box. It's not closed, just so that I can show the electronics and everything. But normally it would be closed to seal the electronics inside with screws, which can be easily removed with the drill, so that you can access all the electronics if anything were to go wrong or you needed to change anything. And yeah.
Alright. Thank you so much for watching, and remember to stay Solen-Safe.